I'm going to prove in this video if L is a mapping from Rn to Rn, so it maps a vector from Rn back into Rn, and it's defined by L of u is just a multiple of u, that is, R is a scalar, then L is a linear operator. Remember, a linear operator is just a fancy way of saying linear transformation that goes from one space to the same space. If this would have been R sub n and the definition for L was well defined, then it would be a linear transformation. So we just need to show the two properties of a linear transformation. Let U and V be in R sub n. So I need to show that L of U plus V is equal to L of U plus L of V. Well, U plus V is a single vector, because I want to think of it as a single vector. You add two vectors, you get a single vector. It's R times it. Now I want to think of them as two vectors. And you have scalar multiplication over addition. You have RU plus RV. But RU is L of U plus RV is L of V. The first one is established. Okay. Let K be any scalar. Okay, so now we need to show that L of K times U, does this equal to K times L of U? That's what we want to show. Okay, so L of K times U. Now remember, K times U is a vector. And what does L do to that vector? What does L do to this vector? It multiplies it by R. We can bring the two scalars together and multiply that by U. We proved that. Now these are two real numbers. They follow the commutative property of multiplication times vector U. And I could invoke the associative law. We proved that too. Now, another name for that is L of U times the K in the front. So yes, I showed that the K can come out. So I satisfied the two criteria to be a linear transformation, or in this case, a linear operator. It's only a linear operator. It is a linear transformation. But since L goes from one space to the same space, we choose not to call it linear operator. Linear transformation. We prefer to call L a linear operator, which it is because it satisfied the rules for linear transformation. If you like quick videos like this, or even long videos like this, please subscribe to my channel. If you have any questions, leave them in the comment section. If there's a video you like for me to make up, just ask. Or most of all, watch and learn.